Yeah, so any questions from homework, go ahead.
I know that this question is solved in the cultures, but I want to know how they solve it in the best way. It's in verse 25.
All right, guys, so we have a question 25 in chapter 1 or 2.
It's 2.3.
So you guys, this is 25 in section 2.3. Yeah, okay. So I told you the book has its own formula for finding percentiles. If I have a list of data and I want to know what percentile 11 is in, right? I'm okay with counting how many are below it, up to it, and then, so I got 1, 2, 3, 4, 5, there's 3 sets of data, 3 data points below it. Now there's a much more complicated formula. The really funny thing to me is percentiles don't mean as much when you have less data points. I only have 5 data points. So what is 11? It is the 60th through the 80th percentile. I mean, there's only 5 data points. So you're going to have a lot of repeats. So you don't have to be anywhere near as precise when you have a very small sample. The bigger the sample is, the more precise this method is, and you still don't need the formula they use. So if you want to use a formula they use, you can. This is just an example problem. This is like section 2.3, asking about percentiles. So the specific question, though, is a little bit different from this. There are a few that are like this. There's a formula you can use, x plus 0.5y bullshit, right, if you want to. You don't have to. This one says, Jesse was ranked 37th in his class of 180 people. Now, ranked 37th, is it relatively good or relatively bad? If you're ranked first, is that good? Yes. 37th. What's the last place person ranked? 180th. So if you're ranked 180, that's bad. Right? You just make up a story that there were 2,000 people, not 180. So rank 37th is good. This is not the 37th percentile then. The 37th percentile, would that be good or bad? In this case, it would be bad. Okay, so if you were to order everybody's grades, would it be close to the top or close to the bottom? The top. So really, you have to do 180 minus 37 to see where he would be in the list. Right? You don't do 37 divided by 180 and give him a really poor percentile. That doesn't make sense. He's ranked 37th, which out of 180 is pretty decent. If I was ranked 37th in the world tennis, I'd be like, holy shit, that's awesome. Does that help on that problem? I mean, it's, once you know this, then you can divide that out of 180. That's the relative position he's in. Out of 180, where is he? Not 37 out of 180. That's not right. He's not 37th from the bottom. He's 37th from the top. Shoot, that's where he's going. Oh, but there we go. All right. Is that decent? So that was number 25 in 2-3. If you haven't done that problem yet, there's little notes for you. Okay. Is that decent? Okay, yes?
I don't know what question it was. I just put the marks on the problem, but it was for number 82.
82 in chapter 2?
Yeah.
Okay. Oh yeah, this is a good one. Alright, so, alright. There is going to be a lot of thought involved in this class. There just is. You're not going to be able to just put the answer down. You actually think about it. This is a really good example of that. This is the one about the median age for U.S. blacks currently is 30.9 years. For U.S. whites, it's 42.3 years. Now, there's a lot of reasons that is, and this gets a little bit into the possibilities of why that is. There's not just one answer for that. There could be a lot of different answers. What does it mean for the median age to be lower for one group than it is for another group? So here's one group, the median age is 30.9. For another group, the median age is 42.3. What does the median mean? What is the meaning of the median? What does it mean?
The half of data is less than 3.4 and half of data is above that.
Yeah, so half of black people are aged below 30.9, half are aged above 30.9. Half of white people are aged below 42.3, so forth. So what would cause that? What's one reason that would be true for the median of one group to be lower than the median of the other group? So watch this. What's the median of this group of data? 2. So the median is 2. What's the median of this group of data?
1.5.
1.5. What happened to it? What's the median of this group of data? 1. Holy shit. What's happening to the median? It's getting smaller and smaller, like from here to there. So what's one explanation? I'm loading things on the bottom end. And in this case, what's on the bottom end? Who are these people back here? These are people that are being...
Rate of childbirth.
These are people what? This is age 0. So if I put more people here, that means that there are more people being born, right? So if one group has more births than the other group, that's going to bring their median age down, isn't it? I'm loading one end up. Now the other possible explanation is the opposite on the other end. I'm decreasing the higher end, right? Which, what would that mean physically here? If I have less things up here,
Just like a lot of old white people.
old white people,
Yeah.
right? Right? And there is a ton of socio-economic reasons, political reasons, all kinds of shit. This is not getting into any of that. This is just talking about the numbers, and you translate it to what it physically means. So those are the two big ones, the two big reasons why that would happen for any group of data. Here you just talk about in terms of ages. Being born, dying. Is that decent? That's this kind of problem wants that thought involved. Think of it from a mathematical standpoint, and then translate it into the English of the problem. If more people are being born, the median goes down, of course. If less people are living older, the median goes down. Maybe? That is what is involved in this class. Algebra is difficult because of all the manipulation of variables and stuff, right? So it's computationally difficult. Statistics is conceptually difficult. I'm not saying it's impossible. I'm just saying that's why you're taking it, because you don't know how to do any of this yet. But this is just think about the problem, right? I can always help you, like right now. So let's see if everybody can kind of gather what I just said into their own words. That would be amazing. I'm just going to play the video back and just write down exactly what I said. That sounds familiar. Yes? Sure. Is that okay? Who asked that question? That's okay? Yes. Good? Good?
Yeah.
No. Tell me. Is that okay? Good enough to work? Okay. I'll let you. Sure. Yes. Okay. So just an example of what I meant by the other thing. If I had a group of data like this, let's see, 1, 2, 3, 4, 5, 6, 7, 8. I like it. What's the median of this data? Yeah, 4, 7.5. I love it. Right? This person dies. Die. What's the median now? 7. What happened to the median? Went down. Do you see what I'm saying? Numerically, that's why one median might be lower than another. So the one situation I did was more down here, which translates into more births for one group. What's the other situation that might be happening? Less people up here, less numbers up here, which translates into ages, which means less people living longer for one group. I like like it. There's a problem about the researchers, and it said, why might they have different data? It wasn't talking about saying because their numbers were different. No, why is the data different? Because the data is different. Next question, Jeff. No. Why physically would the data be different? They were measuring responses to how long somebody lived after they started an AIDS treatment. Why would it be different? Some of you guys mentioned people react differently. Flesh it out. What's that mean? Men and women might react differently. Different ages might react differently. Maybe they have other diseases or other things that are getting in the way. Flesh it out just a little bit. Right? I'm not saying you have to become an expert in medicine to pass this class. I'm just saying you have to think, bring it back to the physical situation of the problem. Okay, I like it. Yes? Oh, sorry.
For the question for 23B, I got a different answer from the book.
That's fine. Especially, is it the percentile problem? Yeah, that's fine. Because the book uses that funky little formula. I almost would rather see a different answer than what they
Yeah,
did.
'cause, I got like 69.
And they got 70.
70.
Yeah,
and then I did
you're
the
fine.
math, and
You're
then
fine.
I got 71.
Oh, that's right.
Yeah.
So maybe they, trust me, there are typos.
So what's the right answer? 70 or 69?
Yes. Because there are two different ways of looking at it. So statistics is the most honest mathematics. Because not only does statistics say, here's what it looks like what's going on, we could be wrong. Like 44% are going to vote for candidate A, 42% for candidate B, and at the bottom it says, plus or minus 4% because we don't know. You know, statistic, and that's why people hate stats, but that's why you should love the shit out of it. If you use it correctly, it's the most honest math. Algebra is kind of dishonest, to be honest. You're just getting used to the nuts and bolts of how to manipulate shit, but it's like, there's always an answer, yeah, no. You get further in math, things get fuzzy. Right, so there are two different ways, at least, to do that problem, and they might come up with slightly different answers. Our set of data is so small that it allows for differences like that. When you have a huge set of data, if you had 100 data points, which is not that big, at least you have one data point for every possible whole percentile, right? If you only have 30 data points, some of them are going to have to double up. And plus, they're careful about repeats, which is, you know, the smaller the set of data, the less that matters. Is that cool? So that's why there are possibly two different answers. They're both close to each other, right? But either one of them is acceptable. Yeah. People aren't used to that. People aren't used to there being a couple different ways to do a problem. And there are, especially in statistics. That's why you have to explain how you got your sample. You have to explain the methods you use. You have to explain the theory you used or the formula you used so people know how to interpret what you find. Yes?
And the same question about the person. When they ask, when we have a data just like 29 and they ask the 78% of it, so sometimes from the answer of the book, they combine two numbers and divided them onto.
Definitely, yes.
How can we become sure that if we just use the number we get?
So remember, what are the two situations for us? If you do the percentage, so if you're trying to find the 28th percentile or something, if you do the first step, let's say you have 70 data points. Right, so if you do the first step, 28% of 70, why'd you do that to yourself, Jeff? Wait a second. 6, 5, is that 19.56, I think? What is it? 19.6, okay. What do I do in that case? You round it up and you take that number. Now, if I did another situation and I did other work and I got 17, then you take the 17th and the 18th and you average the two. So if you get a decimal, you round up, always, and you take that number. If you get a whole number, you average that with the next one. Now think about why that makes sense. What is the median in terms of percentile? The median is the what percentile? The 50th. I like it. So if I have 4 data points, what's half of 4? What's half of 4? 2. Is this the median? No, I take the second and third and average them, don't I? All right, that's the one situation. If you get a whole number, you take that and you average it with the next. That matches up with what we know about median. What if I had 5 numbers? Where's the median? Yeah, what's half of 50? I mean, half of 5. Good job. 2.5. And what? And then I would round. So 1, 2, 3. I would take the third. I would round it up to 3. Take the third number. That would be the middle. That is the middle. There you go. So percentiles just kind of takes the 50th idea and just extends it to every percentile. The 60th, the 28th, or whatever. It's the same process. I like it. Okay. Anything else from homework stuff? Okay. All right, we have one section left. We talked about it very little bit before, the need for this. The mean is not enough information. Right? Remember the whole idea of the teacher that gives from a B to a D versus from an A to an F? So depending on your situation, you want to take one or the other. So that it's much better than just knowing they both give a C. That's not enough information to decide. I also need to know the spread of the data. How far away from that C do they get? One is closer, the other is further. I love it. So let's do, I'm going to do an example set of data. And then I've got a little handout where you guys are going to do your own. This is section 2.7. Bless you. So let me show you the way that data is going to be given to us for the most part in the early part of this. It's going to look like this. Bless you. What's happening up there? Let me put over here another set of data. What you got, Jeff? Which one of these sets of data gets further away from their mean? What is the mean of both of these? Yeah, not just because it's in the middle, but because it's symmetric around 5, right? If you add them up 10, 25 divided by 5 is 5. Same thing over there. So 5 is the mean for both of these. Let me just put that up here. Which one of these data sets gets away from its mean more? The second one. Good. Right? 4 and 6 are closer to the mean. 3 and 5, 7 over there are further away. So the number we're about to create, this is sort of like watching sausages be made. You're going to actually be able to see where an equation comes from. We have something we want to be able to say about data, so we make it. We make it so that it happens, so that it tells me what's going on. The idea here is the spread away from the middle. How far away from the middle do the data points get on average? How do I find the average of anything? So if I wanted to find the average, average age. I would add up all the ages, divided by how many there are. Right? If I want to find the average shoe size, add up all the shoe sizes, how many there are, blah, blah, blah. So if I want to find the average distance from the mean, I add up all the distances from the mean and divide by how many there are. I like it. But let me do one thing here. Change this to a mu before I get too far. I want to do population first. Remember the Greek letters for right now are population, and our letters are samples. The sample formula is going to have one little change, a correction for the fact that it's just a sample. Poor little dude. So what did I just say? If I want to find the average distance from the mean, I have to first get a bunch of distances from the mean so I can add them up. Average blank. Add up all the blanks and then divide by how many there are. So how do I get distance? What operation is distance in math? Don't say absolute value yet, but how do I tell how far apart two things are? I take how far apart 8 and 5? 8 minus 5. Okay, so if I take my data points minus the mean, that tells me how far apart they are, right? There's going to be an issue here that we have to take care of. Yeah, I keep putting X bar on. Most of the time we're going to have samples here. I want to start with the population because it's the simplest. And then we do a little tweak, and that's the sample. Okay. So X minus the mean. How far away from the middle the mean does it get? So of course, what would this be? The mean is 5?
-2.
Negative 2?
-1.
Negative 1?
0.
0?
1.
1? 2. Okay. Now, it's not just because this data is symmetric. What do you get when you add these? What do you get when you add these? 0. Come on. Negative 3? 3. Right? In fact, what's the mean do? It's the middle of the values. Not the middle of the data points, the middle of the values. You're always going to have equal amount negative, equal amount positive. That's what the mean does. So this is always going to add to 0. Good job, Jeff. Thanks. I really want you to see there's a problem here, which is fine. We're going to correct it. We don't... Now, when I say distance, I'm hoping some of you guys remember what really captures distance. This doesn't do it because there's some negatives. I would never say you're negative 2 feet away from me. Even if I turn around, because that would mean they're like inside me. Right? No total recall. So the negatives suck. What's one way to get rid of the negatives? What is really distance in math? What's really distance? Do you guys know? Maybe you don't know. There's a function that always comes out positive. Absolute value. Do you guys know that that is distance? That's why it comes out positive. Do some of you guys remember that? No? Some of you guys never knew that? What's the absolute value of 4? 4. Because it's 4 away from 0. What's the absolute value of negative 4? 4. Because it's 4 away from 0. Ooh, so the absolute value is like the most single-minded thing. It sucks here, though. We're not going to use absolute value. One reason is because, do you guys remember what an absolute value looks like if you graph it? No. Not the symbol.
Okay.
But if I graph it. What's the absolute value of 1? 1. What's the absolute value of 0? 0. What's the absolute value of negative 1? 1. It looks like this. Now, physically, is this a plane that I want to be on? What do I mean by that? If the plane's going like this, and then you go, boom! We are dead. We are pancakes against the... In fact, the plane is probably exploded too. Shit. I don't want to be on this plane. So the funny thing is, I know I'm making a situation that's kind of funny, but people die. Come on. Imaginary people, okay. But I want something that goes through that smoother. Because there's a lot of problems with a function that just has this kink in it. So that really is related to, it's not the whole story. There's a lot more math involved. But that is related to the core of why we don't use absolute value normally. So instead, what's another way to make something always come out positive? Square it. So what we do is, now if I square these, now again, remind me, why am I squaring these? Make it positive, because otherwise they just all cancel and I don't get shit. My spread is always 0. Yay. If I square it, I'm going to have to eventually... If I square these, I'm going to have to eventually do the opposite. Square root it. Because if these are dogs, how many dogs do you own? This column would be square dogs. What the shit is that Picasso stuff? Cubism. Square dog comes running out. Like, I gotta leave. So eventually we're gonna have to square, at the very end, we're gonna square root it. Why? Because we have to square it. Why? Because the stupid negatives. Reminds me of that song, There's an Old Lady Swallowed Fly. But there's reasons we're doing all of these things. So what do you get when you square these?
4, 1, 4.
All right. Now remember, what was it we're trying to get? We're trying to get this spread number. It's called standard deviation. Right? And that's going to be the average distance from the mean. So I got a bunch of distances, they sucked. Okay, I squared them. So let's find the average square distance from the mean and then square root it. So how do I find the average anything? Add them all up. Okay, so I want the average of these. So I'm going to add them all up, become a parenthesis, and then divide by n, the number of them. Because really, here's the formula for mean of something. Just fill that in with what it is. If I want the average y, I'm going to put y's there. The average age, I'm going to put ages there. The average number of beers had last night, I'm going to put number of beers had last night. Add them all up, divide by how many people there were. The symbol for population standard deviation is going to be Greek, again. Just because it's, Greek makes it look all official. It's going to be lowercase sigma. And it's actually, be careful. In this case, I haven't square rooted yet, right? So that symbol has a little square on it, reminding me I haven't square rooted yet. So let me show you. It's like a fat R. You start on the belly and you go around. Start on the belly, go around. Try not to just make an R. Try to make that. It's a Greek letter, so we're not used to making that. What'd you learn today? I learned some Greek. This is called the variance before I take the square root. This is called the variance. That name kind of makes sense. It captures how things vary, how the square distances vary. Once I take the square root, that's called the standard deviation. So that's the formulas for those two things. What am I going to put up here? You never put something in there. It doesn't make any sense. What is x? A lot of things. But what is this asking me to do? What is the top of this asking me to do? Add up all those. Well, I got those. What do you get when you add them up? 10. So that is the sum of the x minus the mu squares. Please realize that's kind of, well, yeah, that's what that is. What's 10? I added up these. Okay, I added up these. So anywhere you see this, what are you going to put in its place? What is it? 10. Remember, this is how you look at the summation stuff in a formula. You say, I need a bunch of those. Okay, we got them. So then I can add them up. You don't put stuff here and here that makes no sense. Sure. Okay. I'll kind of do all this again. All right, starting out. So is everybody cool with the spread definition being the average distance the data points get away from the mean? So if it's 1, that means on average they get 1 away from the mean. That's pretty tight. If it was 100, on average they're 100 data values away from the mean. That's pretty spread out. So the bigger this number is, the more spread out my data is. So for the teacher that went B through D, and the teacher that went A through F, this spread is bigger than this spread. The number here is going to be bigger than the number here. It measures how spread out the data is. That's beautiful. If I know where the middle of the data is, and I know how spread out it is, those two numbers are a quick summary. We can do a lot of shit with those two numbers, and we will. Okay, so, again, I really want you to understand where this formula comes from. You will have a formula sheet, in case you're worried. I let you make a formula sheet. I don't let you put words on it, but I'll let you make a formula sheet. We'll do that together. So how do I find the average squared distance? I add up all the squared distances. Is that cool? To find the average blank, I add them all up, divide by how many there are. So let's do that piece by itself right now. What do I put up top? What is that? Yeah, it's what I got when I add them up. I got 10. Don't make more out of that than it is. So I got 10, and what's n? 5. And then when you square root that, always take standard deviation to at least 3 decimal places. Do you notice how slowly I said that? That is a major note to take. Take standard deviation to at least 3 decimal places. So what is the square root of 2?
1.41.
Right, so it's approximately that, rounded. That's what the standard deviation is. So that is a measure of how far away the data points get from the middle on average. It's not perfect, but it's good to compare stuff. It's not perfect because we had a square, which kind of messed things up in the middle a bit, but we had to kill those stupid negatives.
Is that an 8%?
See again? That's an approximately.
Is that a squiggly on top?
Squiggly on top, yes. Squiggly equals means approximately. I like it. Now, what kind of number should I get over here? Bigger or smaller than this? For that one. What did we say about that one?
Bigger. It's
More spread out. They get away from the mean more often, so the spread number, the standard deviation, should be bigger for this group. If it ain't, we can throw all this shit out and go home. And you're all like, please make a mistake. So what do I do here? Let's do the same thing. What's this? What do I do? X minus mean. I've got to figure out how far away they are in the first place. So the mean, remember, is 5. So this will be negative 2, negative 2, 0, 2, 2. Is that cool? And again, you can see when you add them up, you get 0. That's a quick check. Now, if you have to round, it won't be perfectly 0, but it should be really close to it. This column will always add up to be really close to 0, because the mean is right in the middle value-wise. It'll be equal negative and equal positive. That's why you got to square this crazy-ass thing. We square it to kill the negatives. And of course, what do you get? 4, 4, 0, 4, 4. And when you add up those squared distances, what do you get? 16. And now if I throw that in the formula, obviously I've already got a bigger number. So I should end up with a larger standard deviation. So here I get that divided by the number.
3.2.
Yeah, so you get 3.2, and then when you square root,
1.7.
do it again, sorry?
1.7.
1.788?
Do we round up with that or not?
Say again?
Do we round up with that?
That's what I was going to see. What's the next number?
8.
1.7888? So what do you do with this?
9.
9. Cool. So never just cut it, because then you're kind of being dishonest. So did it work out the way we thought it would? Yeah, this spread was about 1.4, that spread's about 1.8. Yeah, that was higher, it was more spread out. So knowing the middle and how spread it gets away from that middle are two really, really strong numbers. It summarizes the data very quickly. Yes, sir?
You never want us to leave the radical in our answer?
No.
Okay.
Yeah. All right, so let me give you this. On this sheet, I have an example on one side, all the way worked out, with types of questions I like to ask. On the other sheet is your own little problem to work out. So as always, you can work together with other people if you want to. Yes? Yes. Yes. And when it's squared, it's called the variance. I'm not going to worry about that too much yet. I am a major geek, if you haven't noticed, and I love reading about the history of statistics. What the shit, Jeff, really? There's much more things you can do with it. I don't do that all the time. But it's really interesting. Most of this came out of crops. When do I plant to get the best yield? A lot of the early statistical stuff came from that. And from trying to win at gambling. That's another place where it came out of. So one side is completely worked out for you.